Okay, so this afternoon's session we will be considering demand-based technology interventions for the most part, and I'll explain what I mean by that. So I think that this kind of approach and this kind of technology really supports a principle that we're working on back in Britain, because I think this is where managing performance, rail operational performance, your timetable, really aligns well with managing safety, because these kind of technologies have offer the opportunity to reduce disruption and downtime, and also to do safety in a much more efficient, cost-effective, predictive way. And I'm doing some work in Britain with other health and safety regulators, not the rail's health and safety regulator, to try to make sure that as regulators, we are creating the right environment for these kind of new approaches and technologies to be implemented. And for us, that's really, because a lot of these technologies are also developed by actors and companies and people who might not have encountered us as a regulator before. And so it's about making sure that the regulatory framework is really, really clear and well understood, and that expectations are clear at an early stage. And so that's certainly what I'll be thinking about and trying to learn from as we hear from our various speakers. Now, I'm going to introduce our first speaker. It is a slight change to the programme as you have it, just to do with travel schedules and, you know, life happens, you plan, and then life happens. So our first speaker was actually scheduled to speak tomorrow, and so we're pulling him out of a human factors theme later on. But the important thing is that we're going to get to hear from him. So I'd like to welcome James Holly to the stage.
Abby, thank you very much. Good afternoon, everybody. Good afternoon to the chairperson of the Rail Safety Regulator. Thank you very much for the opportunity to address you today, to the leadership of the Rail Safety Regulator, to our government, who is here in attendance as well today, and of course to all of you delegates, and a hearty welcome to the graveyard shift. I hope it's something of interest. So I represent a company called Traction. I'm the chief executive of Traction for my considerable sins, and I have been for about the last 7 years. I'm going to tell you a little bit about our business, and then I'm going to get into what we have done in our business to address the safety challenge of running a rail operations business in 8 countries on the continent. So when we were asked to consider making a submission for one of the talks at the conference, we thought about what is it that really translates to us achieving the safety standards that we do, and we realized that despite the best processes and procedures and amazing assets and amazing facilities, what really brings back outstanding safety is the quality of your people, and the driving force of everything that we are as a business comes back to the quality of our people. And so I'm here today to tell you about our training center that we have developed over the last 18 years. So just a little bit about our business. About 35 years ago, our business started with very humble beginnings, just one employee, a toolbox, and a caravan. And we've grown that business today into what we believe is the largest private fleet on the continent, operating in 8 countries across the continent. And we service about 130 locomotives on a daily basis in the 8 countries where we work, and we have an owned fleet of about 60 locomotives, to give you a sense. The services that we provide are really, just to give you context about what we're going to talk about today, is really limited to rail operations. We don't participate in large sectors of the rail industry, and we don't by purpose. We really are focused in our lane as an operator of trains. And everything that we do is focused on being a highly successful operator of trains. So really what that means is locomotive refurbishment and maintenance is central to what we do. Of course, rail operations is fundamental. The leasing of rolling stock into various customers is very important. Part sales and distribution, technical services, wheel shop is just one example of the technical services that we provide. And then of fundamental importance, and really what I'm here to talk about today, is HR and training. And really, when you go about and looking at and consider how do we conquer the challenges that we face on the continent, we think that the biggest challenge that we have is the skills deficit and the skills shortage in our industry domestically. And how do you go about conquering that challenge of the skills deficit? And really, what we're going to put forward today is how we went about trying to find that solution for our business. And we also realized that we did not have to only train for our business, but we also needed to take a broader view. We needed to take a community view as to how we go about solving this issue for our business. So ultimately, in response, we established the Traction Training Center, and it started also like our business with very humble beginnings about 18 years ago, and it has grown into being really the ultimate foundations of our business today. And we address all of the key areas that we need to address in order to be able to deliver extremely safe and highly efficient operations in the context of the services that we provide. And these are the services or this is what we train in now today at the Traction Training Center, which is diesel electric fitter apprenticeship, artisan fault finding, brake training and brake refresher training, electrical safety instruction, operating safely under OHTE, driver training, shunter training, production coordination for network operations, Shedman training, and then transportation of dangerous goods. We've developed a number of modules into our training center. All of the modules are geared towards what we need for our business. And it's quite important to remember that we focused on our needs. Our training center is not a philanthropic endeavor. We are focused on what we need for our business in order to be successful. And we've now developed about 25 modules that we utilize in our business. So our training center really was crafted in collaboration. And while the training center did start prior to this, it really launched when the Minister of Higher Education and Training in South Africa approved and gazetted the Occupations Qualification Sub-Framework, which enabled us to enhance the scope and the depth of our training school. We brought in a number of subject matter experts from outside of our training school, and we incorporated them into our business. We've spent a lot of time on accreditation, and we started with the Transport Education and Training Authority, TETA, the Quality Council of Trades and Occupation, QCTO, and a National Artisan Moderation Body. And all of those were to give substance to what we do. Ultimately, what that means is that because we're a government-certified training center, when our people leave the Traction Training Center, we, of course, bringing people from our community into our training center in order to employ them ourselves. But when they do leave that training center, they're effectively leaving with a government certificate and a government endorsed training intervention. And that's extremely advantageous and beneficial to the future of the people's lives that we're taking from our community and bringing into our business. We have also taken a relatively unique approach to training in that we've proactively developed our training materials to match our industry's requirements and assessment criteria. In other words, we, by certifying our training officers with the Sector Education and Training Authority, or SETA, our assessors and moderators are able to do their own government-certified moderation of our people, which has also added another important element to the training that we provide. We've also realized that because our training is focused on really operations, that it's important that we look outside of that, and we don't only focus on the specific training that we provide to our people. So we have also looked outside of that. And in the last 5 years, we've provided 55 internal staff bursaries into a number of other training requirements for our business that we don't specifically provide ourselves. And in many ways, the training that we provide is extremely practical, real sort of spanner-turning stuff. So we partner with people like the University of Pretoria in order to enhance the training that we do even further. And to give you a sense, in 2022, we spent an average of 44,000 Rand per employee across the entire business on training interventions on all of our staff. And all of that, well, what does it translate to at the end of the day? And as I've said, this is not like, this is entirely predicated on making sure that we are a successful, commercial, and profitable organization. And really what it has translated to is that our employee retention rate was 93% last year. Our customer satisfaction rate is 91%. And we have maintained a 5-star safety rating over the last 5 years. And in that period, we've had 3 consecutive 12-month periods within the last 5 years of 0 injuries in an entire calendar year. We've enjoyed growth in our business where we've grown from 2 countries to 8 countries. And we've had revenue growth of 62% over the last 5 years. So also translating back to really the most important thing, ultimately, which is also commercial success. We've invested into our facilities as well. We've invested about 100 million Rand, for example, into the first phase of our rail services hub in Pretoria. And we've also then taken another step of having that facility accredited by TITA and QCTO. So the facility itself is accredited as a training center by them as well. And in addition to the 100 million that we've invested into this facility, we've invested about 800 million into our total business in the last 5 years. I'll touch on in a moment. I'll touch on why. So what this also means now is that we offer 25 rail-related courses ranging from NQF level 3 to 5, and we conduct on average about 700 training interventions on our staff. To put that into perspective, we have 400 people, and we do about 700 training interventions internally on our staff. But we also offer our training to third parties, and we have been offering our training to third parties now for about the last 5 years. So into numbers, since inception, we've trained about 700 drivers and 700 artisans. And remember, the artisans go through an extremely rigorous course to attain that level. So we are now offering training in 8 countries in Africa. Most of those are areas where we are operating ourselves. I'll give Senegal as an example. We have sent a fleet of locomotives up to Senegal on full maintenance lease. And in Senegal, they are going to be driving the trains themselves. Their railways have not been in operation for about the last 5 years. So we've taken 18 of their drivers who haven't operated for a number of years, and we're doing dedicated, detailed training on their drivers to utilize our assets. And that's extremely important for them to be able to deliver efficient and safe services. But you can understand on the other side of that, it's extremely important for us too, because we can ensure that our assets are operated by people that have the kind of skills and ability that make us confident to give them our assets to operate for us. And again, it comes back to the skills shortage being the primary challenge that I think that our railways are facing on the continent. And this is our solution to try and find try and close that gap. So a huge part of our training is our apprenticeship program. We take people out of our local community, out of the TVET colleges, and we enroll them into our diesel electric fitter apprenticeship program. The program is a 3-year course. We write all of the training materials ourselves. We have our own trainers, and then, as I've said, we have our own assessors that are also qualified to be able to do the assessment of our technicians as well. And at the end of 3 years, after going through this rigorous training program, we now have people that we are confident we can put onto the maintenance or refurbishment of our assets, which at the end of the day are what generate the revenue for our business. Another part of this and linked to this is our ability to give back. And we do, as you can see, firmly believe in working in our community in order to realize the success of our business. So as part of our corporate social investment, we provide disability learnerships. We provide donations to an orphanage at Shoshanguve, which is a township near Roslyn, where we are based in our main workshop complex. We've adopted a school also in Roslyn, where we are assisting them with power backup solutions to their school. And of course, together with the rail safety regulator, we're working on educating communities about the importance of safety. And we enhance that also with our own Shrek campaigns. So looking forward, and as we go into the next phase of rail development on the continent, we've got to say, how are we going to solve this problem? If our belief that the biggest challenge that we're facing at the moment is across the continent is a skills deficit, and we're going into a really interesting phase in our railways. If I go back, say 5 years ago, as a private operator, we were able to operate our trains in Mozambique. And today, as a private operator, we can operate our trains in Mozambique, in Zambia, in Tanzania, in Namibia, in Zambia, in the DRC, Gabon, Senegal, and very, very soon in South Africa. It's creating a huge opportunity for private operators on the continent, and that's why we've invested so much into our businesses in preparation for this opportunity of private trains entering into the African market, operating under third-party access. I was chatting to Mike Howard, who's here earlier, exactly very similar to they do in Australia, and he's going to be giving a very interesting talk tomorrow on this, which I think is a great precedent for how we try and solve this problem. But when you have a moment of extraordinary growth, how do you solve the skills problem? And it's a very important question that I think we need to be asking ourselves. In addition to the questions about how do you raise the money to invest into new trains, how do you raise the money to invest into the quality of the infrastructure, to upgrade the infrastructure so that we can make sure that you can achieve the efficiency out of your trains when you do invest into them. But a critical question is, how do you invest into the people to make sure that we have the people of the quality that's going to be able to deliver these services in a successful way. So we feel extremely passionate in our company about trying to change the way that freight moves. Everything we do and everything we believe in as a business is how do you change the way that freight moves in Africa, because we have this enormously dominant trucking industry in South Africa and in Africa, rather. How do we change the way that freight moves to be properly balanced between what should move on trucks and what should move on rails for the incredible benefit of the upstream economy? And if we in a business invest in R1 billion of trains, R1 billion of trains for a new rail service, let's say to a developing mine, we'll probably employ about 100 people, highly skilled people, in order to operate those R1 billion of trains, which is excellent, absolutely excellent. It's a great thing. But what really makes us excited as a business is that mine is going to create 3,000 jobs or 5,000 jobs, and that mine happens as a consequence of being able to have a reliable rail solution that they can stand on to invest into in their minds and in their mind, and that's the exponential benefit that we get out of our business and what we do, and all of that comes back to training in the very first instance. So yeah, thank you very much. That's me.
Good afternoon, ladies and gentlemen. I'm David Yam from the Electrical and Mechanical Service Department of Hong Kong SAR government. And it's my pleasure to share with you on our proof of concept project on the train-borne railway infrastructure inspection system. These innovation systems can accurately and automatically inspect railway infrastructures assets in a tunnel during the passenger service hours to enhance the efficiency of inspection works by facilitating the trend analysis for the predictive maintenance, and also help to free up more non-traffic hours for other trackside maintenance works. So as introduced by our Mr. Chen, the Electrical and Mechanical Service Department is the Railway Safety Authority in Hong Kong, responsible to regulate the safety of mass transit railway, tramways, and pit trams. And we are also taking the role as innovation facilitators to support and facilitate the railway operators on application of INT in advancing the public service and developing of smart cities. So let's take a look on our on the railway network in Hong Kong. The railway network in Hong Kong has a massive volume of access. There's some of which have been used for over 40 years. And also, the railways has operated with very long service hours, typically 19 hours per day. So our colleague says we have only 2 hours golden maintenance window per day. And also, so it will be the extremely challenging task to conduct the maintenance of tunnel infrastructure with extremely short maintenance period. And also, for our traditional approach of daily visual inspection on the railway network infrastructure, which is very labor-intensive and time-consuming. So, for example, at the railway network in Hong Kong, have the 270 km in Hong Kong, and if you use the traditional approach of manual inspections, we will require about 7,200 man-hours per line per year. So this is really the challenging task. So for this project, we have made use of the E&M Inno portal, which is the online technology demanding matching platform established in 2018. EMSD had using this platform to collaborate with railway operators and also the university to initiate this pilot INT project to have the proof of concept on the train-borne railway infrastructure inspection system. So so to move on, let me show you the video for the introduction of project. Thank you.
The railway network in Hong Kong consists of 10 heavy rail lines with massive volume of railway assets, some of which had been used for 40 years, and the railway operates with very long service hours, typically 19 hours each day. It is an exceedingly challenging task to conduct maintenance of tunnel infrastructure with extremely short maintenance period.
With a view to replacing manual inspection for filling up more non-traffic hours for other maintenance works, the Electrical and Mechanical Services Department collaborates with trade and university to look for an innovative solution which can accurately and automatically inspect railway infrastructure assets in tunnel during passenger service hours.
The project team utilizes various advanced technology, including SLAM in LiDAR, stereo computer vision with advanced AI algorithms, dual-band infrared imaging, and edge computing with 5G technology for infrastructure inspection. and development of a train-borne infrastructure inspection system. The 4th generation LiDAR with SLAM technology produce a precise 3D point cloud for mapping and positioning of train and infrastructure defects inside the tunnel. The LiDAR is capable to scan the surrounding environment at speed of 0.1 second per rotation, with 2.6 million points per second. And this new technology allows tunnel inspection to perform at 80 km per hour. The position accuracy is within 1 meter, which is more precise than the traditional GPS or Bluetooth positioning solution. These 3D point cloud images can also be used to generate a 3D BIM model for asset management. Combining stereo computer vision and advanced AI algorithms can significantly widen the view of scene and the depth of view. It also enhances the accuracy of identifying infrastructure defects, including concrete spalling, cracks, water seepage, and detection of abnormal trackside equipment displacement. The AI algorithms can also provide prediction on the worsening of infrastructure defects. The dual-band infrared imaging, shortwave and near-infrared bands expands the dynamic range of IR detection for distinguishing concrete cracks and water seepage inside the tunnel. Edge computing with 5G technology empowers instant defect detection and ultra-low latency data transmission on the passenger train. This is the world's first passenger train-borne inspection system capable to detect at 80 km per hour tunnel infrastructure defects in the railway's tunnel.
This innovative solution fully utilizes the advantages of SLAM and NIDA, advanced artificial intelligence, and imaging technologies. This is also a pioneer solution in the application of these technologies using real-time data obtained during the normal operation of railway services. The most outstanding feature of this solution is using versatile sensors and installing them on the passenger service train. The system enables real-time monitoring of the infrastructure condition and trackside equipment. It provides actionable information to the maintenance team to make an appropriate decision or to take remedial actions. For example, prioritizing and scheduling the maintenance work. Such a system will certainly enhance the safety and maintenance efficiency of the railway operation.
Smart maintenance is one of MTR's initiatives to provide safe and reliable train services in Hong Kong. Apart from the introduction of innovative technology, it is also important to our maintenance staff to learn how to best use the technologies in their duties. For example, we have been using visual inspection methods to check the conditions of railway tunnels during non-traffic hours. With new technologies, we can conduct our inspections more effectively and efficiently. As the MTR network continues to expand, the corporation will continue to go smart and go beyond with the community.
The system has been put on trial on a passenger train with promising results. We trust that this innovative solution will help to further enhance railway safety, and it can also be beneficial to other trains which require an efficient and effective solution for inspection and monitoring of their infrastructure assets.
Okay, so this invention is the world's first train-borne high-speed scanning system designed to detect and predict tunnel infrastructure defects while operating at a speed of 80 km per hour. So by using the technology with advanced features, this system has the capability to identify concrete spalling and cracks, and detect the water seepage, and also monitor the displacement of trackside equipment within the tunnel. And all while the train is traveling at the high speeds. So this project has been honored with the Distinguished Silver Medals Award at the International Exhibition of Invention of Geneva in 2023. So this showed the key components of the system, which involve the LiDAR sensor, and also we have the near-infrared cameras, and also the short-range infrared cameras, and also the edge computer with the AI model for preliminary scanning on the real-time videos. We will go one by one in following slides. At the first, the system is equipped with the 4th generation of LiDAR, which enables the simultaneous localizations and mapping positions, which can produce a precise 3D point cloud for mapping and positioning of train and infrastructure defects inside the tunnel. And also, we make use of that 3D point cloud. We can build a 3D BIM model. This will be treated as a reference position of trackside equipment. And then we make use of the AI model to compare the reference position and the current position of trackside equipment. And then if there's and the AI model will predict the trend and provide an alert to maintenance staff when the displacement of trackside equipment exceed the definite limit. And also, for the detection of the infrastructure defects, we have made use of the stereo computer vision and computer visions. And the system has 2 sets of cameras installed at top of the train head, just like a pair of human eyes. And combining the stereo computer vision and advanced AI algorithm can significantly widen the field of scene and the depth of view. And the system will have applied 2 AI algorithms. That is the YOLO V4 for the preliminary scanning, and also the Dino for the detailed identification of defects. So this will enhance the accuracy of identifying infrastructure defects and also provide the trend prediction on worsening of infrastructure defects. So the system has also applied the dual-band infrared imaging, which are operating in near-infrared and short-wave infrared. So the rationale behind is that since the water has the higher absorption rate at the short-wave infrared bands, so the inclusion of that infrared band can easily distinguish the concrete cracks and also the water seepage inside the tunnel. Lastly, the system also equipped with the 5G edge computing, which can facilitate the real-time detection at high speed and the fully automatic inspection during the service hour. So this edge computer also conducts the preliminary scanning by using the AI algorithm before sending to the cloud server. So this shows the stage of the real-time videos captured by LiDAR and infrared cameras will undergo 3 stages of processing. In the first stage, the lightweight AI YOLO version 4 embedded in the edge computer on the train will perform the preliminary screening on the real-time videos. The abnormality identified from the preliminary screening will be converted into static photos and then sent to the cloud server with 5G network. So in the second stage, the powerful AI model, Dino, on the cloud server will perform the detailed identification of defects and positioning. Finally, the report with details of defects will be generated by the cloud server. So this showed the target result of our proof of concept project. We target to identify those defects with overall detection accuracy of 80%. So let's see the test of and the results of the project. And in the left-hand side, this is the stage 1 of the result. That is the picture from the preliminary scanning by YOLO model on the passenger train. And then and the right side, that for stage 2, that is analysis by the Dino AI model on the cloud server. So we make use of the stage 1 result, and then we have use those AI on the cloud server to identify those defects. And this is the report generated on the cloud server. So the reports will cover the defect types, with detection times and locations, which enable effective decision-making and target maintenance actions. For the trackside equipment displacement, we have tested with various simulated scenarios to evaluate the system performance. And the simulated scenario include the displacement of protection barriers, opening of tunnel radio amplifier doors, and the presence of abnormal objects in the high-speed section. So the system installation and testing were completed with trial runs since March 2023. And the proof of concept test was conducted in a designated 150 meters tunnel segment along one of our rail lines used over 40 years. This specific section of railway infrastructures was selected to provide a representative environment for evaluating the performance of AI system under the normal operating conditions. So we have about 5,000 training data sets and 200 iterations used for each detection. The detection accuracy of concrete spalling, crack, and water seepage were all over 80%. For the trackside equipment displacement, we have made use of about 6,000 3D point cloud frames collected with resolution of 65,000 bytes, and we have detected all the similar scenario of trackside equipment displacement. And the accuracy range for the positioning defects location is within 7 meters after using those fixed point markers to the specific position along the point cloud. So for the further enhancements of this project, of course, if we're getting more data for the machine learning of AI model, we can further increase and enhance the detection accuracy. And for the positioning of defect locations, since the proof of concept project are conducted in the tunnel without much unique features, if we can use those, we can identify and add some unique features within the tunnels and then add into the 3D point cloud for the AI analysis, we can have further accurate defects location positioning. So in conclusion, the train-borne railway infrastructure inspection system represents a significant advancement in the field of infrastructure condition inspections. So by using the artificial intelligence, the system greatly enhanced the efficiency of railway infrastructure conditions inspections. And the system also facilitates the trend analysis on detection and prediction of railway infrastructure defects. It can facilitate the proactive maintenance planning and timely intervention, ultimately leading to improved safety and reliability of railway network. Lastly, the system can accurately and automatically inspect railway infrastructure access in tunnel during the passenger service hours for freeing up more non-traffic hours for other trackside maintenance works and optimize the utilization of maintenance windows. So thanks for your attention.
Good afternoon. My name is Ayanda Bani. I'm working for PRASA. Greetings to everybody, including my CEOs and rail CEOs and everybody else. The presentation is about traction reliability, okay? Traction network reliability to improve the customer experience. So I am very pleased to be working for an environment where you know when you have done something, the customer is happy on the other side. So whatever we are trying from our side, we are trying to solve all the problems to make comfortable ride for the customers. So I will talk about the market share or intermodal split in the region, rail network performance, maintenance philosophy, fault analysis, network recovery and redesign for reliability, and a little bit on the SCADA for integrated systems. Okay, from the network point of view, everyone has this dream of having one network system integrated, where you can have one ticket to take a bus, to a train, and to a taxi. So this is the intermodal split for the national rail network, including all the transport modes of transport. So you can see from, if you are looking on the Western Cape side, from 2003, we're getting 34% of the share of the network, of the transport. And 2013, we're improving to 37% at that moment. Before, we went down before COVID. And if you look at the other regions, then you will see for the Eastern Cape, we're around 4%. Okay? So this is the cost comparison for all the modes of transport. So for transport cost, it costs about 30% of our salaries. And on the other side is the mode of work trips based on the quantiles. So if you look at the train side, the people that are using the train, you can see it's about 6% on that side. And also the people that are using buses, you can see the share from the top. Quantile 1 and quantile 2, the number of people that are using the trains is more or less the same, but as you go along to quantile 3, then the number of private cars is increasing as you go with the big salaries. Okay? So in terms of the performance for 2013, 2014, and to 2014, 2015 financial years, this is what we were during that time, 79% for Western Cape, and we slightly decreased from 2014 to 74%, and KwaZulu-Natal was 82%, and they decreased as well to 79%. This is the intermodal split for the Western Cape region. So you can see all the shares in terms of the 15% that is used by people are using minibuses, minibus taxis, 11% for passenger rail, and 7.9% for contracted buses. This is the network of the Western Cape. And if you look at the numbers in terms of what we were transporting, in 2013, you will see it's 636,000 people. And we were slightly going down over the years. So for us to get back to where we were, we need to understand, as the engineering field, the maintenance philosophies and strategies. So in terms of our maintenance is based on reliability-centered maintenance. So it requires intensive asset maintenance management system. The goal of asset management is to meet a required level of service in the cost-effective way through the creation, acquisition, maintenance, operation, rehabilitation, and disposal of assets for present and future customer needs from the Institute of Asset Management in the UK in 2002. So these are the elements that are required as the building blocks in terms of when we improve the system. So the infrastructure, rolling stock, train operations, and customer services, and the support departments, which is the human capital, finance, SCM, ICT, and security. And this is the life cycle of an asset, which I will not go through it at the moment. So for reliability-centered maintenance, these are the types of maintenance strategy that focuses on functional, failure modes, analysis, research on failure types, as well as failure modes and effect analysis, and preventative maintenance. This I will also not go through it, is the life cycle of an asset where you will have to do interventions to keep the asset to its standard. And these are the requirements for us to move forward. The design standards, operational requirements, maintenance requirements based on failure modes, and effect analysis, as well as the risk assessment. So for us to achieve all of that, we need tools, equipment, machine, and people. At the same time, when you have the people, you require different levels of skills. So if you have, if your asset is critical and the asset is complex, then it means you require high sophisticated personnel. So if your asset is not critical and your asset is not complex, you can do with a simple or low-level personnel. Okay? So in terms of those stages where you have the asset that is critical, so it means now you require a high level of skill in terms of the people that will be working. If you look at the machines that are required for the railway network and also the energy meters that are required in the substations network and also the axle counters on the signaling system. And based on your maintenance, then you have your job cards in terms of the people that are working on the network. So for the design for reliability, what you need is less or few faults that you will get on the system, and you also need quick response, and you need effective or fault-finding techniques, and you need to fix the fault quickly. So these are the building elements that you use for the reliability of the network. So this is the availability, because the customer is looking at the train, is the train available when it is required. So for us to achieve that, our network then needs to have a redundancy in terms of having 2 transformers in 1 substation and also feeding 1 line with 2 substations. Okay, from there, major faults that we have is more like pantograph hookups and derailments, and electrical control at this stage is not able to see what type of fault was there, even though they know there is a fault, but you can't tell what current was at the time of the fault. And also we have personnel patrolling the lines when there are problems on the network. So what you do also and check in terms of the breakers that we have in the system. You check how many times does a breaker trip, what was the fault, and what was the fault current at that moment. So you will know in terms of the number of trips on the breakers. So this is the 33 kV network where we are getting a supply from ESCOM, and then we distribute it through our network in the region. And this is the 11 kV network as well that we manage from the region. This is the management information that we get in terms of the number of faults that we get. This was for 2014-2015 financial year. And these are the faults that are affecting the running of trains in this network. Most of them being the pando hookups. In this case, if I will give an example, from October to January, you can see the number of pando hookups are normally high in the areas where the areas that are hot. For example, the line from Belleville ESD River to Stellenbosch, in that area. So we have reduced the frequency in that area. We have increased the frequency in those areas in terms of the interventions on the network. So this is the TGIV test where we are testing, getting the results for section insulators. If there are exceptions there, then we are able to go to the network and verify what is in there, or what is the fault from that side. And this is the rail network, also the defects on there. So these are the faults that we get in the system. So I've just taken the ones of August to see the number of faults per department in the areas. So, and then we also get issues where we have trees that are touching OHTE, because you have a network that is running inside their communities. So the trees don't belong to the rail network, but they belong to the city of Cape Town, but they are growing over your network. So it's things that you need to manage as in the system. So to minimize the faults in the system, so what we have done, we have acquired fault path indicators as well as energy meters. The energy meters were really for energy meters, energy management in the network. So we have reduced the foot patrols using the fault indicators. This is an example of fault indicators in the 33 kV network. Okay, where it tells you the position of the fault, where it is, and you are able to check all the faults. This is an example of a fault where you have a fault current of 839 amps. The second one was 876 amps in the section. So this is the energy meters that are installed in the substations. So when we have you will know the consumption on the network, and you will also see the faults that are happening. So you do the trend analysis and get the type of faults that we have. So this is the way of detecting the faults that are coming. This is also an example of an energy meter that was installed in a train itself, where you analyze when the train is passing through a section insulator, where you will see whether there is a problem on the section insulator. So as the trains are passing on the section insulator, you collect data in the section. Then you will see if there are abnormalities in the section insulator. This is a typical example of a measuring tool for stagger height on the conduct wire and the slope of the conduct wire. And this is the analysis of different trains in the system, where we have the old trains versus the new trains. So you get the trends in terms of what is the performance of the train itself, and if there are problems, you will see you will see them before. So I just put an example of a recovery plan for the signaling system, where we are moving in terms of trying to get the system where it was before. This is still an example of a signaling system. And also in terms of protecting the network, this is one of the tools that the team is using from our network in terms of protecting the assets. You can see it's the Excel counter, but it's inside what we call a silo, and it's protected by 2 silos, and also the Excel counter head also is protected in that area. So as part of the recovery, and also in terms of upgrading the network, the transformers, it's part of upgrading the high-speed circuit breakers to minimize the faults in the network, and also where there is more vandalism in the sections, we're putting the cables in steel poles in the section, and also we're replacing the wooden doors with the safe security doors in our substations. This is a typical example of a SCADA system. This is more on the simulation system. So based on the analysis that we are doing in terms of improving the reliability, we have also tried to extend the 33 kV network so that we can have different feeding points in the section. While we get the power from ESCOM in different point of supplies, then we reconnect all our network in terms of improving the reliability in the network. Okay, I've just added, this is the poster outside. It's about energy management, traction energy management solutions for energy efficiency and load shedding. If you are interested on the poster that is outside. We are using the same energy meters that are for energy management system. We are using them for the network reliability, to analyze the system itself while it's still working okay, but you prepare yourself for the faults that are coming. You can see it's not what it's supposed to give you now. Then you will see that there is a fault in the system. So that is my presentation. Thank you very much.
Yeah, very good afternoon, one and all present over here. I'm Anjana Pidas. I'm coming from Tata Elxsi Limited. My office is working in Trivandrum in India. Today, I belongs to the transportation business unit of Tata Elxsi, and today I'm going to give you the advancements in the rail track inspection solution, what we have, and especially on the topic this multi-component detection, especially to understand the defects in rail joint bars. Yeah, before moving on to the topic, let me introduce Tata, India's most valuable trusted brand, and which is having an industry more than 150 plus years. And Tata is having business in almost all sectors, coming from the automotive, infrastructure, retail, lifestyle, finance, travel, and in IT segment. In IT, you can see the Tata Consultancy Services and Tata Elxsi are the two premium companies which we focus on IT-related service and products. And I belongs to Tata Elxsi. We are in business from 32 years plus, and we do have business in transportation, media and communication, and healthcare. And coming to the transportation, we do have business in automotive and off-highway segment, in passenger experience, advanced driver assistance systems, autonomous building blocks of autonomous driving systems and all. And we are into rail industry, especially in the smart mobility, track inspection, perception-related solutions, computer vision, artificial intelligence, and then the rolling stock maintenance, then the wayside signaling. So, coming to the global presence, we are headquartered in Bangalore in India, and we do have presence across the globe in North America, Middle East, Asia Pacific, Japan and all. Coming to our specific areas where we are focusing in the rail industry, one is especially the asset inspection maintenance for the safe and efficient railroad operations. Coming to the services, that is the autonomous system, where we do have the perception-related systems, the sensors, especially the camera, LiDARs, radars, GPS, IMUs, and based perception solutions. Then into the rail platforms and the in-cabin solutions, we do have platform passenger convenience solutions, unattended baggage detection, child passenger detection, blind passenger detection, and providing personal convenience systems. So these kind of platform services and in-cabin solutions we have. Similar to that, we are in the seamless, the IoT and cloud connectivity-based services as well. Yeah, coming to our inspection scopes, as we were hearing from the morning onwards, the demand and the significance of digital infrastructure inspections, right? So the track inspection, when we look, we do have a wide varieties of defects, and that has to be periodically monitored, right? Especially in terms of the geometry of the curvature, the cross level, the static measurements, then the structural part of the missing components, loose components, then sometimes as with the damages, the breakages, the cracks, the one we have witnessed about the cracks in the tunnel, similar to that, cracks in the rail tracks. Those are some cases. And coming to the rolling stock, we do have the coupler inspections, the structural deformations, then in the engine as well, the brake systems, the loose. So all those areas we do have, we can bring the digital solutions into these systems. So coming to the track inspection solutions, as we were hearing from the morning hours, the significance of manual inspection and how people are doing inspections currently, and even in the inspection vehicles as well, it's a kind of contact systems where we have to, it creates problems in the normal operations while we trust on these kind of systems. Here comes the significance of a non-invasive or contactless systems where we can do efficient inspections and more trusted and reliable. Yeah, here are the few components which usually lead to the derailment causes. One such case is this rail joint bar, and we know that it is having many components like nut and bolts, maybe 4-bolt arrangement or 6-bolt arrangement, depending upon the geography. Geography and the standards, the safety regulatory standards which we are following in on different geographies, the structures will be different. Wherever it is, in which geography it is, the safety, the process, the common practice, what we followed is same, right? That means it has to be properly tightened and it has to be correctly in the place. So as we know, most of the times, in some cases, there we can see some loose nut conditions or a missing nut and bolt conditions or this kind of, and even the joint bar itself will be missed. So these are the very critical situations where we have to do inspections. Coming to, you can see this in the image. It is having 2 nut and bolts are missing where we can see a dark holes over there. And in some cases, it will be loosed on the right side. You can see the loose nut. So these are the different structures where exactly we have to identify. Yeah. So, yeah. As I said, particularly it is made up of, it is using multiple nut and bolts, and there should be an insulation, and it's having multiple components altogether we can see. So, and all these components should be in the proper place so that it will be functioning properly. And coming to the other cases, at some cases we can see these kind of breakages. This is a very evident breakage. But in some cases, we even see some hairline cracks. The hairline cracks itself, it's a kind of an indication for an upcoming derailment. So even if we could able to identify or we could able to dictate all such scenarios well in advance, it will be good to prevent such derailment causes. So how can we, how can we do such cases? Currently, we can see a lot of manual inspections, human efforts we are putting into this. And we can see, there will be human errors as a shortcoming of these manual inspections. There will be disruptions, the time consuming, and of course it is labor intensive, and it depends upon the geography, the climate, weather, all these things will be affecting by this manual inspection. And here comes the significance of non-invasive systems, especially the images, the systems, certain systems which we have seen, the LiDAR-based systems, similar to that, a little more cost-effective and faster systems that will be more obviously camera-based systems. And one such non-invasive thing is we can connect the sensors in the drones, and we can fly the drone and we can capture the image. One important thing is it won't affect the normal operations of the railroad. Even if we can connect the camera sensors to an inspection vehicle itself, it will be good. But even if it is drawn, advantages and disadvantages are there, because we'll be getting the images from the very big height, and should be very good quality, high resolution cameras to be placed so that get the clear view of these minute components in the track. Anyway, we have vermin solutions, which is completely based upon these camera images. The solution is a kind of collecting images from the field, and it's completely a post-processing solution. Either it can be deployed in the edge computing devices, or even if we can deploy the solutions in the cloud and transferring the data to the cloud, and we can do an analysis over there. So the solution what we have developed, it's not only detecting the defects, it could even measure the intensity of the defect. I could see one example. You may be aware about the static gauge. It's a horizontal distance between two rail tracks. We can even measure the gap within the camera images by considering the ground sampling distance, the GSD, the ground sampling distance of the image. And another measurement case, we can see the turnout switch. The turnout switch gap, that is a very critical component in most of the places, and it is very vulnerable to defects as well. In some cases, in some structures, it is the gap is to be 3 mm or 1/8 inch or this kind of small gaps. Even that gap we can measure from the camera images. And that is the one good thing. We can understand the defects, and we can measure the intensity of the defects using the camera solutions. So it's altogether, the solution, the algorithms, what we have is kind of a hybrid, algorithms, which is kind of a cascaded approach. Multiple AI models with advanced computer vision techniques form the algorithms to achieve, good accuracy in the sense which is it's an ensemble decision-making approach that offers 95% and above accuracy, where we have tested with the different geographies within the India and other geographies as well. Yeah. Lot of new technologies we heard from the morning onwards. With artificial intelligence techniques, we can even measure the tunnels, we can even understand the defects of the tracks. So many options are there AI can provide. But one global challenge what we could face is a lack of data. Lack of data in the sense, we understand we can collect the data from the field. We have millions of kilometers of track globally, and every country we do have a lot of tracks, and we can collect the data from the track. How the cost factor, that is the one thing involved in that. Apart from that, in order to build a reliable and trustworthy artificial intelligence model, we do have to maintain the data diversity and data balance within the data set. For example, if it is a breakage detection system, in order to create a good data set, we should have normal data, defected data in a data balanced manner. Most of the times, for these kind of, our rail infrastructure inspection use cases, we don't get that much data balance, because normal data or non-defected data we have, but defected data, it is difficult to collect, because that is compared with the normal data, it will be less. Here comes the significance of synthetic data generation. We have a synthetic data generation tool in-house we have developed, which is based upon multiple things. One is, of course, the parent data, which we are collecting from the field. Second is, we even create the physical models resembling the actual field data. The third is, we can even create we can automate to create the 3D models of the components, especially the one which I explained, the nut and bolt situation of the tracks. And these parent set, we can even use to generate millions and millions of data. We have the customized generative AI tools, generative AI algorithms, which is customized especially for the generating the rail track components. And these customized generative AI techniques helps to generate more data. Then other option is we can even generate using the conventional computer vision techniques as well. We can generate more defected data. So this synthetic data generation, that is a one globally, I could say this is a demanding thing which we rail track inspectors has to, the digital rail track inspectors has to look on. So we have the tool, and that's how we have developed millions of data to train our models and create efficient models. You can see a few of the cases of the missing nut and bolt combinations. The one image is the source image from that using the customized generative AI technique. What we have what we have generated is the multiple combinations of the missing nut and bolt conditions. So this is one such example. Similar to this, we can apply the same things. We can customize, we can generate models for other use cases or other problems as well. So, yeah, coming to the multi-component detection. The problem here it is, identifying the missing nut and bolt detection. So coming to the object detection, object detection, especially the one which earlier we heard about, the YOLO, the ULE Lucans, which is one popular industry demand object detection algorithm. While we're trying YOLO, what we can see is it's just if it is a single object detection, will be very difficult because, as I mentioned, it's a 6-bolt arrangement. Most probably in the data, there will be fixed nut and bolt conditions will be more compared with the missing nut and bolt condition. So here comes, even if we are planning to create a object detection using YOLO, we will fail for sure because there is a lack of data balance within the multiple objects. Here comes what we have did is we experimented on multi-component detection so that even from the one image itself, in order to, our primary goal is to detect missing nut and bolt condition. Even if that is the case, we do detect nuts, bolt head, missing nut and bolt, all the conditions as a multiple. We framed it as a multi-component detection. So it worked well for us and it provided reliable accuracy, good accuracy, more than 95% in all the tested images in multiple geographies, in India and in other geographies as well. So this is the version 5 of YOLO, what we have tried, which provides the good accuracy. And this is some of the statistics of the hyperparameter tuning, what we did in order to build a reliable model. And what we can see is, it's providing good results in terms of accuracy, precision, and recall. Yeah. That's the entire, what we can see, the entire rail spec, that means the rail track inspection solution that is highly automated and it is not impacting on the normal railroad operations and it enhances safety and cost, which we can see it can be 50 times saving in the time for inspecting the same road compared to the manual method. The one which I presented is a multi-component detection, especially in the rail joint bar. Similar to that, the intelligent solutions for 100 plus track inspection defects we have, and two other use cases as well. I have the posters which is available outside on, especially for the overlapping ballast analysis, and another one is the crack defect detection. You can have a go, you can visit that as well. Yeah, that is the end of my presentation. Thank you.
Right, thank you very much for this opportunity for us to introduce MTR. Today, you have already heard about the name of MTR, but who is MTR and what are we doing here? Right. Let's share a little bit about what we are going to do today. We have the topic called the machine vision-based tunnel equipment inspection system. Right, before going into the very details of the technical part, perhaps I should really introduce ourselves a little bit. I, together with my partner Shira, is actually coming from the innovation team under the MTR. Right, the vision and the mission of MTR is to keep city moving. We see ourselves not just a railway operators, but a company to help to keep the cities moving. In particularly, we would like to not just help Hong Kong moving, but to help a lot of the cities moving at the same time. We would like to grow the community whenever the rails reached, because people would very love to actually reside, work, or live, or just stay next to or near to our station and railways. We would like to provide a caring service to our passengers, our customers. At the same time, we would like to go for innovations with reasons, and I'm going to talk more about these reasons. Well, MTR is no longer a local company in Hong Kong. Actually, we have reached a lot of different continents, in Europe, in Asia, and also in Australia. But do you find that we have missing some presence in Africa? So hopefully one day we will have some kind of collaboration with Africa, in particular South Africa. Right, you will notice that these boxes have different colors because we are running the business on different natures. Some are actually we are running the operations. Some actually we are doing the project. Some actually we are doing something outside railway. In fact, we are also doing property development and management. We are also hiring trains, like in Sweden, right? So why we are going to do so many different dimensions? Because it is not easy to run a railway self-financed. That's why we have to explore other business opportunity to allow us to finance our operations. Interestingly, in fact, Hong Kong is not gaining any support directly from the government, but in fact, we are paying dividends to our government. Right. In fact, although MTR is running over 3,000 kilometers of tracks around the world, but only have around 200 plus kilometers of railway in Hong Kong. We are carrying more than half of all the patronage around the world. We are having 1.5 billion passengers a year. That accounts to around 5 million of passengers a day. Earlier, we were talking about a very high reliability called the 99.9%. But what does this mean to our passengers? If you are a passenger, you take the trains once a day. It takes you 3 years to experience a noticeable delay due to whatever reasons. So that is a very high standard we have set for ourselves. In fact, today, in the last few months, we have achieved a reliability of 99.95 and above. That means that you are not going to experience a noticeable delay by traveling 2 times a day for 3 years. We have 98 stations, and we also run a light rail system having 68 stops. While we said it is a light rail, in fact, it is a very heavy light rail because we are carrying 500,000 of passengers a day. Well, with this kind of scale, complexity, and heavy usage, how could we actually keep up ourselves with the demand? That's why we go for technology in innovations. There are 5 words in our minds. Seamless. That means that we would like to have good connectivities for the passengers, from lines to lines, from stations to stations. The next one is a challenge. Personalized. Just imagine we have 5 million passengers a day. How could actually provide some personal information and personal service to our customer one by one? That's why we have go for technology, making use of all the mobile apps, knowing their profile, and try to customize our recommendation to them. Inclusive. Well, we carry nearly half of the public transportation in Hong Kong. But we also have to take care of those that have some kind of disability. The wheelchair users, the visual impaired, and also the hearing impaired. That's why we would like to adopt some innovation technologies and try to help them out. This is part of our aim. Efficient. We're talking about operations. In order that you could sustain ourselves and be financially self-sustainable, I think we have to run our railway in an efficient manner. Not only that, we also have to run our railway in a sustainable manner. We have to go for green initiative, and at the same time, anything we introduce to the network, we need to measure a little bit on the financial viability. Well, soon we will have the Q&A sections. But before that, may I ask all the audience one question first? Now, if you were me, running a railway of such a scale, such a crowdiness, such a demand, but we have a lot of work to do, either for the maintenance or for the upgrade or the expansion. What are we going to do with that? Okay, maybe I should ask my partner, Shira, to answer that for me. Okay, Shira, it's time for you.
Thank you. Thank you, Mr. Chen. To move on, just now we have heard a lot of different presentations from our representative from Hong Kong, EMSD. They mentioned about we have that golden 2-hour window. So just want to give you a bit more context on it. What does it really mean that it is a 2 hours window? Well, actually, we run a service of 90 hours a day. If you deducted it by 24, it should give you 5 hours remaining, right? So say from 1 a.m. to 5 a.m., there's the time that we close our service. We spend around an hour on preparing for the work, the safety of the maintenance work. We have to set up the boundaries, the protection of people, so that we will make sure the people who are working on the track won't be being hit by an unexpected train or other incidents. And right before our service resume on the other day, we have to make sure everything that we have done on the track has been safely removed. And this is what we call a track check before the start of service. So what remains, these 4 hours, what remains is actually 2 hours for work. Imagine the scale of our network, the assets that we have to maintain, 2 hours each day. This is what we have to make sure that our track, our trains, our overhead line, our civil infrastructure is safe for the operation. So that comes to mind that is, how can we make use of technologies to help us resolve some of the problems? From the demand side, obviously, it's because we want to conduct more inspection tasks, collecting more data so that we can drive different business impacts, different decisions for our maintenance. We want to do more with the resources that we have today. And from the supply side, because we see that the use of machine vision has become much more mature these days, the AI technologies that our friends has also mentioned earlier in the presentation. So actually what we see is that in these 2 or 3 years, these kind of technologies has been successfully being applied in other industries. For example, in the production, in factory side, also on the road vehicles. And we think that it's time for us to try introducing these kind of technologies in railway industry as well to see how they can fit into our O&M. And finally, applying technologies is one thing. Whether we are able to really derive this kind of business impacts out of it is another thing. So for us, in terms of unleashing maintenance productivity, is really to minimize the need for human intervention when we introduce this kind of new technologies so that people can focus on higher priority tasks. So this is the project that we would like to share today, which is the machine vision-based tunnel equipment inspection system. So what you can see on the right-hand side, it is a locomotive. There's a very, very small box, a silver box. If you can see, it's just next to the light, a silver box that's square in shape. That is the camera. Inside that, in the middle of the slides, a picture of the small camera, the black one, and also the power adapter that is right underneath. So you can see we are not trying to put in large equipment, large system onto the train, but in this project, we're trying to put the small equipment and see if AI and machine learning can help us in our task. The kind of camera that we have chosen is a high-speed, low-lux camera. As you can see, it looks more like a commercial product rather than an industrial camera. We have been strategic on that in our camera selection because we know that if this is a commercial camera that can be used in this situation, in the future we know that we don't have to rely on a sole supplier to produce this kind of very sophisticated camera to us. Actually, we expect that in the future of the technology advancement, more and more this kind of commercial camera can be used so that we can have different suppliers providing us different kinds of cameras in replacement of that. And the project focuses on the computer vision that we apply computer vision on the images being captured from this camera, and the result is the middle below bottom picture that shows as long as the locomotive is running on the track, it will collect this kind of video images continuously. And the AI algorithm will be applied into that and then detect different kinds of equipment that is found inside this tunnel.
While we are still sorting out the technologies, perhaps Shira could still talk a bit more on how we are going to show all this information to our engineers to have to handle all the infrastructure maintenance along the tunnels.
Yeah, maybe that video didn't work, but anyway, I can try to supplement just by it. Basically, what we do is the locomotive, it runs on the track and it collects different information. I'll use this to explain further. It collects different images that comes back to our system. So the human intervention in this will be minimal because the system will start itself. As long as the locomotive is being turned on, the images will be collected. And the locomotive will be dispatched to its maintenance site to carry out the day-to-day maintenance. So while it was doing so, more images are being captured along the way. And when the locomotive finishes duty and returns back to the shed, these kind of images will be uploaded to the server automatically. And when the images are being uploaded to the system, it will conduct its auto comparison with the baseline that we have prepared earlier to see if there's any dislocation, abnormalities, disappearance, or new appearance of equipment. So you can see that actually the whole process, it doesn't involve a lot of manual operation in it. From the user side, it's actually quite transparent. For them, it's just staying inside the office and receiving a report telling them that if there's any new findings from the last inspection of the locomotive. So here's a quick comparison. In the past, currently, we are doing inspection by patrolling. In terms of resources efficiency, it is not that high because we have to dispatch a person to walk on the track every 2 or 3 days of a week, within a week. And the standardization of the inspection quality and outcome varies because it depends on the person's experience and how they are going to collect this kind of information. As we move on to the vision-based inspection, because it is a standard algorithm, it's a standard camera, the camera is installed at the same height of a locomotive, everything that comes back is highly standardized. And the way that to judge whether something is an abnormality is also based on the set rules. But the question that you may ask is that, whether this machine vision-based inspection is already able to replace some kind of patrolling inspection. And that would be a no, because for patrolling, you actually have the time and be able to go on the site to do the detail measurement and the fault finding. While machine vision is a quick and dirty way to identify, highlight this kind of systematic differences, inspection by patrolling will be able to allow the people to go there and do detailed inspections. So it's like one is more on the rough and dirty side, and the other one is more on the detailed inspection side. Okay, so these are also some captures from the system, the images, the videos. From our system, it will be able to tell the maintenance team what kind of equipment were identified in this defined area. This is being done automatically. It doesn't require the maintainer to input any information into it. The actual location of the individual equipment, the number of count of those equipments, and on the right side, that will be the video images for them to easily visualize where exactly those equipment are. There's also a reporting function that will output where they are, the location, and where any abnormalities found. Yep, and there are a lot of different data that we have collected from systems. This is only one of them. We also implement other smart technology systems in our railway. So the question is, how do we make use of this data from different systems to generate different ideas?
Thank you, Shira. And now we have the data. We have the analytic result. Is it the end of the story? We are saying that no, it is just the beginning of the journey of the data analytic. Because data in the silo form would not tell us a lot. But data, when integrated together, will tell us a little much more. And then we will have a lot of insight coming from that. I may just quote 2 examples. passengers may have the feelings that our trains are very crowded. Our system is a little bit loaded. But there are 3 reasons for that. One is that all of a sudden, there's a surge of passengers entering into the station. That could be captured by the ticketing information. But there's also another reason, is that actually our train frequency or the headway is not enough, or some sort of delay. So this is being held, data being held by the signaling system and the train arrival information. But not only that, we still have one more piece of information that's very important, is whether the train coming into this station is already full or not. If it is not full, no worry, because the train is going to take all the passenger away. But if the train is already full, then the passenger will feel that the system is very crowded. And these are 3 different kinds of data. So in order to ease our passengers' concern, we have to integrate all the 3 together. So this is what we are talking about, the data integration. Another example is talking about the technical part, is the maintenance side. If you are riding on a train and you feel a little bit of vibrations, there are possibly at least 2 reasons. One is that your bogie and your wheel is not good. It's not round enough. Another one is that your rail is not flat and smooth. That's why you have this bumpy ride. So it is only when all these 2 sets of data are integrated together, then we know that, what is the exact reason for that. So this is why we talk about data integrations. That's why around 3 years ago, we have set up a so-called data studio in our network that help us to collect all the data into one place, and we try to actually process all this data together and try to get some information and insight from that. Today, we have around 30 sets of data, and we are now trying to see if we could actually relate one with the others. So this is the setup of our data studio. Look complicated, but it is simple to illustrate. Do you have a smartphone with you? I'm sure you have. You have the hardware, the smartphone. It would not work unless you have the iOS or the Android. This is the apps, the OS. And then it won't work unless you have all the applications downloaded and installed. So for this data studio, it is also divided into 3 layers. The bottom layer, the green part, is all the hardware and the processing power and the storage. But this is all certainly in a much bigger scale. The blue part is all the OS or standard application that you have to put into the machine in order to let them start to work. But we need to have the data input. So the data and all the applications are on the top layer, so that we could actually run this at the same machine and try to generate some of the insight from that. Last but not the least, on your right-hand side, we talk about cybersecurity, because for this kind of data, some are rather sensitive, and we must have a very robust control and protection of all the process. So this is how we have set up our data studio. So this ends our presentation, and we welcome any questions. Thank you.
Thank you. 2 questions. Okay, lovely. Thank you very much. That was very interesting. Well, we have time for 2 questions. So get voting if you want your question to come up to the top. So we have a question from Natalie for Mr. Yam. I think it's similar to the question I asked you. So once you've gathered this information, fault information, what are the operational processes? Do you or MTR have the decision available to stop traffic?
In fact, for EMSD, we are served as inspectors, so we do not have the authority to suspend the traffic. This project is just the proof of concept, so the operator will remain the responsibility for the safety. And I would like to supplement that this project is to collect the information for the trend and for the trend analysis to facilitate the predictive maintenance. It's not for detection of emergency conditions.
Okay. Very good. Thank you for that. So this question is from Dr. Malobi. It's for Mr. Ayanda Bani. In your maintenance philosophy, how do you manage spare parts obsolescence or discontinuation?
We're not supposed to ask difficult questions.
No, it wasn't me.
So we had issues with the obsolete assets where the OEM is no longer supporting those kind of assets. So it's issues that are there in every industry. But from our side, it's an opportunity now because we are recovering some of the lines from our side and some of the substations. So then our substation will be based on the current technology that we have. We had transformers from 1957. So we have those, even the switch gear from that age. So, but at the moment we are replacing all those with a new technology.
Okay. Yes, wonderful. There were really good questions. If you asked a question or have a question, please do find our speakers this evening or tomorrow. And I'd just like to ask you to thank our speakers one more time.